Hey guys, welcome to Environmental Engineering 280. This is lecture 25, wastewater treatment 2. Okay, and today we're just going to be doing one simple example problem. So let's get started. So we're given that wastewater treatment uses an activated sludge process for secondary treatment of zero point 0.3 cubic meters per second of primary effluent, and mixed liquid, well, it's really the MLVSS, the suspended solids, has a concentration of 2,100 milligrams per liter, and the RES concentration is about 10,000 milligrams per liter. And you don't want to get thrown off by these two. I don't know if you would have read this wrong, but the VSS, both of these have those units. You're not going to use one of them, okay? But well, let's see what we're actually asked to find. They give us the FM ratio, the food to molecule ratio, or not the molecule, my bad, guys, the microorganism ratio, and well, we need to know the equation to do this problem, so we're asked to find the volume, right? So the equation we use is Fm, right? There's a way I memorize it, like Fm ratio, right? F over M is equal to Qs, I don't know, like quick scope, I don't know, Qs divided by Vx, like Vex, without the E, right? So also, what does this all mean, right? So that's your food to microorganism, not molecule ratio, right there. And your X, that's basically your V or your MLVSS, your mixed liquid volatile suspended solids, and that's actually given us to us right here. Okay, we don't have to use the RES concentration, so don't get those mixed up. And Q, that's just the what do we call it? The inflow, the flow rate, right? And that's given to us right here actually. The effluent is 0 0.3 cubic meters per second. S is our substrate concentration. That's also given this to us right here on 220. But the substrate concentration, if they don't give it to you like down here in this order, you gotta know what it's called, right? V is what we're trying to solve for, and FM is given to us as well. So let's go ahead and just use this equation, right? So our FM ratio is basically given to us right here. Is 0.52 milligrams. So 0.52 milligrams of BOD, biological oxygen demand, divided by milligrams of VSS times by D. Okay, that's really long. Our Q is 0.3 cubic meters per second. And our S, that's just 220 milligrams BOD 5 per liter. And that's all divided by our equation here. We're trying to find V, and we got to find what, or we know what X is, that's given to us, which is, make sure we don't use the wrong one here, 2,100 milligrams of VSSL. So right away, we can see that this L and this L would cancel right here. This BOD and that BOD would cancel. But one of the biggest things is I almost missed it myself, is this D right here. That's given to us in days, right? And we want the units to be the same, so I'm just gonna go ahead and convert this 0.3 to the side, right? To days instead of meters cubed per second. So 0.3 cubic meters per second. Well, we have to multiply that by, let's do it over here. Get more space. We multiply that by 3,600 seconds in 1 hour. And we know that there's 24 hours in 1 day. So if we just put that on the calculator, we get 25,920. So if we replace that everything's in days now. So this day and this day will cancel. Now everything cancels out. Great. I mean, now we're just left with cubic meters, and that's what we're looking for. And this cancels with that too. So now we just gotta get V by itself. So we just gotta solve for V. So if we do 2, 5, 9, 20, multiply that by 220, divide it by 2,100, and we divide that by 0.52, we get 5,221.98 cubic meters. And see, that's actually pretty close to our given answer here. So yeah, that's it for this problem, guys. Thanks.